So I have my first foldable ready here. So I am going to go through this with you. Now what I'm going to do is I'm actually going to just talk through it, and then I'm going to have you pause the video so that you can write it down. Okay, I'm going to put an S right there so you can see the word segment. Okay, so the three that I have starred, point, line, and plane, these are called the three building blocks of geometry, meaning everything else that we talk about in geometry builds off of these first three terms. Okay, so we call them undefined because they don't really have a set definition. They have more of a description to them. Okay, so again, I'm going to go kind of fast. I don't need you to write down now. We'll pause. I'll give you time to pause and fill stuff in. Okay. All right, so point is a location in space. It is just represented by a dot, like it's the tip of my pencil, it's the iris, the center of my eyeball, it's, this little speck right here on the table. All of those are represented by a dot. Okay, so this is point A, point B. They don't have any size to them. It doesn't matter how big I draw that circle, it's still a point. Okay, the key with naming points is that they're always using capital letters. Okay, so we could call it point A. You don't really have to write the word point. You can just write the capital letter. If you see a single capital letter by itself, that's always going to represent a point. Okay, so you can pause, write that down. I'm going to go on to line. A line is a straight path. It goes forever and ever in two directions. And so we have two arrows, one on either end of our line, showing us that it's going to keep going and extending. Like if I grab these ends and I extended it forever and ever, like a piece of string or, a really long measuring tape or something like that, right? That's going to represent a line. This line has no thickness to it, so no matter whether I use this thin marker or whether I use a really fat marker, it's all the same. Okay, it's just representing that line. We're going to use 2 points to name it. Okay, any 2 points. So I could use these two letters, C and A. I could use A and T. I could use T and C. I'm going to pick any 2 of those letters, and I'm going to put the symbol for line over the top, which you should be familiar with from middle school. So this is line CA, or we could call it line AT, or we could just call it line L. Sometimes out here at the end, you'll see like a little lowercase or a little cursive letter out there, and that could be used to name the whole line as well. Okay, again, notice that we don't put any points on our symbol down here. We just use the arrows, and we don't put commas or anything between our points here. Okay, this all represents our line. Okay, again, pause, get it written down. I'm going to keep going. You can rewind if you need to. All right, so the third of our undefined term, or our building blocks of geometry, is the plane. Okay, so if I took a whole bunch of pens, or I took a whole bunch of lines and I laid them out on a flat surface, okay, they would end up becoming a plane. Okay, so a whole bunch of points together make a line. A whole bunch of points together in a straight line, that makes a line. If I take a whole bunch of lines and I put them side by side, they're going to keep going forever and ever in all directions. Okay, so it's going to make the flat surface like the top of my table or the floor or the wall or the ceiling. Okay, flat surface extends forever in all directions. So we use this parallelogram, not a rectangle, a parallelogram that's kind of tipped off to the side to represent our plane. Okay, and what we need to see on our plane is we're going to usually see 3 points. And do you see how these 3 points make this triangular shape, the way they're written out? Okay, that's the 3 points that I want to use. Any 3 points that make a triangle, I can use those to name the plane in any order. So this could be plane DOG, could be plane DGO, GOD, any order of those 3. And again, you can write out the word if you want, or you can just write the 3 letters. If you see 3 capital letters like this without commas or anything between them, this all together represents one plane. Okay. Every now and then you might see a single letter up in the corner. It's not going to have a dot next to it, no point next to it. It's kind of in italics or fancy lettering. You can use that to name the whole plane as well. It's kind of a shortcut, plane R. Okay. All right, so our other 3 terms that build off of that are going to be segment or line segment, ray, and then opposite ray. We're kind of missing the O there. It's back there, whatever, it's good enough. All right, so a segment is if we took this line, it's part of a line, and we like removed the arrows, right? So if I looked at just this part and I said from C to T, that would be a line segment. It doesn't go forever and ever. It has a definite length, okay? And it has a definite starting point and a definite stopping point. And it doesn't matter which way you're going. You could draw from K to J or from J to K. It's going to be the same length. So part of a line with two endpoints. Every now and then they'll have some extra letters in the middle here, but I can cover up O and it's not going to change the length of our total segment. Okay, so we only use those two outer points when we're naming our line. Only two letters, JK or line segment KJ, segment JK, segment KJ. I'll get them right. Okay. All right, then we're going to go to a ray. Now, when I think of ray, I think of like a ray of sunshine. So that starts at the sun and comes down to the earth. So a ray is a part of the line with one end point, or a starting point really, but we always call it the end point. Okay, so like this is the sun, starts at the sun, and then it's going to come forever and ever down, and it's going to hit the ground, and it's going to keep going through that because it's ultraviolet and it's, you know, dangerous and stuff. So one endpoint goes forever in one direction, has one arrow. Okay, so when you're naming this, you're always going to start at the end point. That's the most important part. Where does it start? And then what direction does it go? So it's going to give us another point to go through, and then it's going to keep going after that. So we name this MC. Start at M, go through C. It's going to look like this. MC with the ray symbol over the top going to the right. This is the only way we ever write it. Okay, we're not going to write it backwards like this. The arrow doesn't go this other direction. This is wrong. Okay, this is not ray CM. This would be ray CM with the arrow going that way. However, that would not be this picture. That would be this. If I start at C and I go forever through M and I keep going forever and ever out this way, so the arrow would be out past the M. That is not the same as this. Okay, so naming the ray is probably the one that's the most confusing. And the last one we have is the opposite rays. They're just what they sound like, opposite rays, two rays that go in opposite directions. Okay, now these are not opposite directions. Okay, opposite directions is like one going to the left and one going to the right. Okay, or north south or east west, opposite of each other. Two rays that go in opposite directions. They share a starting point. Okay, and what does this look like? What do opposite rays make? Opposite rays make a straight line. So going from A to B is the first ray, ray AB. Going the other way, starting at A, going through C is ray AC. And together they make a straight line. Okay? All right, so that is our first foldable. I'm going to set that off to the side. Don't lose that. Okay. And I'm going to grab the second foldable. Okay, this one we're going to talk about collinear and non-collinear, coplanar and non-coplanar. I'm going to pause for just a second to fill mine in so that I can go through it quicker. Okay, I'll be right back. All right, so we are back. We are going to continue looking at our next foldable, which has these words on it. Okay, so first things first, what word do you see inside this word, collinear? What word do you see? Okay, so some people might have said linear, some people might have said line, some people might have said col, except that's not really a word like that. Okay, so I see the word line right here, and I see a prefix of co. All right, so the prefix of co comes from words like co-worker, cooperate, cohabitate, okay? When you have a coworker, you work together at the same job. When you have, when you cohabitate, that's from social studies, those are people that live in the same house or the same area, or the same village, right? They cohabitate. People that cooperate work together on the same task. So co means same. So collinear means points that are on the same line. Points on the same line. Okay, so if we have points that are on the same line, we draw a line, we put a whole bunch of points on it. All of these points and any others that we were to draw on there would all be collinear. Okay, and now notice, since I listed 4 points that are all collinear, I separated them with a comma because I'm listing them separately. If you don't put commas between them and they just all stay together as one answer, or one almost looks like a word, right? That means it's a plane or part of a shape. Okay? All right, pause if you need to. Non-collinear. Okay? Non means not. Co means same. Linear means line. So non-collinear points are points that are not on the same line. Points that are not on the same line. So I drew an example of a line, I put a couple points on it, and then I drew 1 point that fell off the line. Okay, if you can connect points with a ruler, with a straight line where you don't have to curve or take an angle or do anything like that, those points are all collinear. If you have to veer off of that path to get to another point, that tells us they're non-collinear, not on the same line. C, A, and T are not collinear. Okay. All right. So what do you think coplanar? Coplanar. Okay. Now I know some people see the word plan, but plan doesn't really have anything to do with geometry. What word did we just define that sounds sort of like this? Plan. Instead of plan, it's plane, right? So a flat surface, plane. So coplanar means points that are on the same plane. And non-coplanar will be not same plane. Points that are not on the same plane. Okay, so an example of that, I'll get my definition here. Any points that are on the same plane. Any 3 points that make a triangle will be coplanar, even if they don't have this plane drawn around the outside of it. If I just took 3 points and I made them in the shape of a triangle, they will be coplanar. I could put a plane there. Okay, so this plane FOG is coplanar. If I want points that are not on the same plane, okay, I could have some points that are here on the plane, and then I have one that fell off. So if I listed these 4 points and said, are they coplanar or non-coplanar, you would have to say not, because this one like fell off the table, right? Like all of these points are sitting on the tabletop on the flat surface, and then this one fell on the floor. There's no 5-second rule here. We're not going to get up there. Okay. All right. So let's look at these examples that are here in the middle. Okay. And I'm actually going to have you stop and answer a couple of these as we go and see what your answers are. Again, you're not getting graded on this as far as whether your answers are correct or not. I just want to see where you are, okay, at this point. Okay, first things first, in this picture, when things are black and white, it's a little bit hard to see how things match up. So I want you to grab 2 colors real quick, or you can kind of shade differently if you want. I'm going to color this part of the plane, whatever color this is, yellowish orange, and the rest of this plane is kind of sitting back here at the back. Okay, so all of that, like think of that like a piece of paper that cuts through like that. Okay, then my other plane going the other direction is this one. So maybe if you don't have 2 different colors, you can just draw your lines the different direction. Maybe that will work. Okay, so this is our other plane. Okay, so I have a plane going like this, and then I have another one that's cutting through it like that. All right, and then this line that kind of heads down the middle. Okay, so question number 1. Are points F, A, and Y coplanar or non-coplanar? So look at points F, A, and Y. So these 3 points, do you think they are coplanar or non-coplanar? Pick your answer. Okay. Is there a plane going through those 3 points? No, there is not, but could we put one there? Do the 3 points make a triangle? Yes, they do. So these points are coplanar. Any 3 points that make a triangle will make a plane. Okay, even if it's not drawn in the picture. So that was maybe a trick question. Let's see if we can do a little bit better on this next one. The next one says, are F and Y collinear or non-collinear? So here's F and here's Y. Are those collinear? Are they on the same line or are they not on the same line? Did you pick collinear? Even though there's no line drawn that connects them, we could draw a line between them. Even though it's not there, they are still collinear. Any 2 points make a line, no matter what, no matter where they are. Okay. All right, next one. Are points F, R, and B, F, R, and B. So here's F, here's R, and here's B. Are those points coplanar or non-coplanar? Coplanar or non-coplanar? What did you pick? Non-coplanar. They are not on the same line. In order for them to be coplanar, they must make a triangle to be a plane. Right? So since these make a straight line, what do we call them? This is our answer to the last one. Are points F, R, and B collinear or non-collinear? Collinear. Same line or non-same line? FRB, collinear. Same line. Duh, or whatever you want to put. Sometimes it's just that easy. Okay, so do you see how this can be? It can be a little tricky as we're going through, right? It's kind of hard to see with the picture. So again, this might be new. Take your time, ask questions, work through it. Please don't get discouraged. Okay, so let's fold that one back up and we'll set that one off to the side. I'll put my other one. Okay, and we're going to grab the last one. We're going to talk about intersections. I cut part of that off. Intersections. Let's see if I can get the rest of that word. Intersection of lines and planes. Intersections of lines and planes. Good enough. All right, so here we go. 2 lines intersect. All right, so I'm going to model for you 2 lines. Here's one line, and here's another line. Okay, this is called parallel. Okay, so in order for them to intersect, they have to cross, and they are going to touch at what? Okay, so I only have one of 3 answers. They either touch at a point, they touch at a line, or they touch at a plane. So do they touch at a single spot? Do they touch at a line like the intersection of your 2 walls in your house, like the corner? Okay, all of that becomes the line. Or do they intersect at a flat surface, like a ton of spaces all the way across? Okay, what do these cross at? They cross right here at a single point. You can even use your fingers if you want to be lines. You can cross them like this and see where they cross. Okay, 2 lines intersect at a single point. At a point. So this point right here is where our 2 lines intersect. Okay. So for example, name the intersection of line LM. Here's line LM going this way, and PM, which goes, there's P, there's M, so that's that line. Where do those two intersect? They intersect right here at M. And remember, when we name a point, it's a single letter all by itself. Okay, so you don't ever want to have any more than one letter there. Okay, all right, what about two planes? All right, so I'm going to show you two planes. I'm going to show you two planes with this piece of paper and this Post-it right here. Okay, these are my two pieces of paper. When they intersect, see how they touch? Okay, see how they touch all the way down here? All of this is the intersection. This is not intersecting. This is like, see how they become one? Like this is now one piece of paper, right? Okay, so if they intersect like this, they're touching. These are like my two walls, right? Corners of my bedroom, like this. Okay, all the way along here and going forever and ever, because if this is really a plane, it's not just this sheet of paper. It's actually going to get bigger and bigger and bigger all the way, and this is going to get bigger and bigger and bigger forever and ever. Okay, which is kind of hard for us to visualize sometimes. So two planes will intersect all the way down at the line. Think of the walls of your room. Two planes intersect at a line, like the walls of your room. Two planes intersect at a line. Okay, so I'm going to draw the line in like this, right down the middle of those two. Okay. All right, for example, name the intersection of plane D and plane A. So where is plane D in this picture? Is it the one that goes left to right or the one that goes up and down? D. This is the D right here. So this is plane D. And then this one is plane A. So where do they intersect? Where do they touch? They touch here at X. Yeah? Is that the only place where they touch? Nope. Do they touch here at R? Do they touch here at Z? Do they touch at all of these other points in between them as well? So what have I just made? So far I've made a segment, but it has these arrows on it and it keeps going forever and ever in both directions. There's the line. So how many letters do I need to name a line? 2. So pick 2 letters off of this line. X, R, with the little line symbol over the top. Or you could have put RZ, or you could have put ZX or XZ. Any of those combinations would have been the same line. Okay. All right, and the last one. The last one says a plane and a line. Okay. All right, so here's my plane. I'm just going to use my hand, and here's my line. Okay, and I'm going to make them intersect. Does this intersect? No, those sitting on it. Okay, so I want to intersect, so it's going to go like this. Okay, so imagine it might actually like go all the way through. Like imagine if you stabbed your pencil through a piece of paper. Okay, where is my line, my finger, touching the plane, my hand? At a single point, at a line, or a flat surface. It doesn't touch the whole flat surface. It just goes through this one spot. So a plane and a line will intersect at a single point. Okay, single point. Right there. So imagine stabbing your pencil through your paper. Okay, that's that one point where it's going to go through. All right, name the intersection of plane HEF and line GC. Okay, so I'm going to color in plane HEF. Now I'm going to show you what people do that's wrong. Sorry, I didn't know that. Okay, people do this and they say this is the plane. Okay, those are the 3 letters used to name the plane, but the plane is that entire flat surface. So if you think of this like a box, which it is, this plane, whoa, what happened? Y'all still there? This plane is this entire top of this box. Okay, so this is the plane that we're looking at, this entire top. HEF actually goes all the way around to G. And then we have our other line that goes from G to C. Okay, and what I just colored in is not a line, it's a segment. So I want it to keep going with arrows on either end and keep going. So the question is, where do those two things touch? Where does this line touch this plane? Right there at G, right? Just at that one spot. Doesn't even cut through it, just kind of skims across it. Okay? All right, so make sure you have everything filled in. If you need to go back and pause anything, you can do that. And then bring these with you to class when we meet next. And we will do a couple examples just to make sure we're all on the right page and all understanding. This is a little tricky, but again, this is going to kind of set the tone for the remainder of the year. So we want to make sure that we're good with this. So we're going to spend a little bit of extra time on it. Okay? All right. I will see you next time. Love you. Bye.